right, we just finished up talking about layers of the earth, both by their composition or by their physical properties. And hopefully there's some part of your brain that's thinking like a scientist, and you're thinking to yourself, these layers are so deep inside the earth, how do we know they're even there? And that's a really good question. And that's what we're covering today. A big part of us discovering these different layers inside Earth all deals with the energy released from an earthquake. We call them P waves and S waves. And this is energy that radiates out from where an earthquake takes place. And this energy that leaves an earthquake can be found all over the planet. So it spreads out like ripples in a pond across the entire planet, and even someplace on the opposite side of the world, in some cases, can record an earthquake. But as these P waves and S waves travel through these different layers, they sometimes are refracted or bent, and sometimes they're just stopped altogether. And this produces areas called shadow zones, a shadow zone. And that's where we don't receive any seismic waves. And if you look at the diagram of both P waves and S waves traveling through Earth, you can see that the P waves, when they hit the liquid outer core, they refract or they bend. And then when they go from the liquid outer core back into the mantle, they bend again. So this refraction, this bending that takes place, has made a chunk of Earth's surface receive no seismic waves at all. And that means it's a shadow zone. And if you look at the S wave, as soon as those S waves hit the liquid outer core, they are stopped altogether. And that's just because S waves cannot travel through liquid. So that right there gives us clear evidence that there are liquid layers inside Earth. Some of the boundaries that we found using seismic waves was the MOHO. The MOHO is a boundary between the crust and the upper mantle. It goes from where rocks are being more rigid, rocks acting like rocks in the crust, to more of that semi-solid plastic flow mantle. Another boundary that we found that I've already mentioned is the boundary between the mantle and the liquid outer core. Again, producing shadow zones because S waves cannot travel through liquids. Also because P waves refract when they hit this liquid outer layer. When it comes to the composition of layers, some of these layers are pretty easy to figure out. Because when we talk about the composition of the crust, we can walk around on the continents collecting material, and we can figure out that the composition of the crust is granite, it's felsic. Same thing with the ocean floor. We can actually take core samples, we can drill the ocean floor, we can hold it in our hand, and we can tell what the ocean floor is made out of, basalt and gabbro. When it comes to layers like the mantle that we can't drill down into, we have to think a little bit harder about the composition and how to figure out the composition of those layers. There are unique situations on Earth's surface, like Hawaii, where there is material erupted that doesn't match the composition of the continental crust or the ocean crust. So then scientists had to think, if this lava material, like in Hawaii, isn't coming from the crust, where is it coming from? And the answer is the mantle. So these rare circumstances where we have these lava flows straight from the mantle, we still are getting samples of the composition of the mantle. The layer that takes the most effort and kind of discovering the composition is really the core. The core is furthest away from the surface. It's a place that we can't get to, we can't take samples, and it doesn't erupt to the surface. So how do we know that the core is mainly made out of iron? And the answer is simply meteorites. We know that Earth is bombarded, and it has been through all of history, by meteors that are mainly made out of iron. We can sample these meteors, we can pick them off the ground, and we know that when Earth was forming, our planet had even more of these impacts. But if we look at the composition of the crust, we look at the composition of the mantle, we don't see the quantity of iron that we would expect to find here on Earth. So if it's not in the crust and it's not in the mantle, the only place it can be is in the core. If you have any questions on anything we talked about today, please make sure to ask. Otherwise, thanks.